All right, number 8. A 15-gram bullet strikes and becomes embedded in a 1.1010 kilogram block of wood placed on a horizontal surface just in front of the gun. If the coefficient of kinetic friction between the block and the surface is 0.25, and the impact drives the block a distance of 9.5 meters before it comes to rest, what was the muzzle speed of the bullet? All right, so looks like we got a gun here, and this block of wood is attached to it, or says right at the end of the muzzle of it. And it's going to strike the wood, and that wood is going to slide some distance here, right? 9.5 meters. And you got some friction happening through here until it's a mu 5. And at the end, the final velocity of 0. What was the muzzle speed of the bullet? So basically, what was the initial velocity coming out of the gun? Initial velocity of the bullet. So, let's see. That bullet, just tracking the events here, that bullet is going to hit this piece of wood, right? Yes, there's a gun there, and it's going to travel. Okay, so it has some initial velocity when it strikes that block. Collision. So then you have block with bullet. Now they both have some velocity. Presumably it has some very strong velocity of the bullet. And this started at rest. Collision. Now they're both moving together. And it's going to slide, force of friction, or maybe think of this more like work done by friction. I like that idea better. Work done by friction until they come to rest with no velocity. Okay. All right. Let's see here. We know how far it travels. We know displacement. We should write all this stuff down. Well, we kind of already did. Displacement, I'm interested in 9.5 meters. The mass of the bullet is 15 grams, which is equal to 0.015 kilograms. Mass of the wood, block of wood, bullet, they both start with B, so we use B and W for this. B and W, not B and W. Mass of the wood is 1.10 kilograms. Initial velocity of the wood is 0. It's kind of like you got situation A, then situation B, and then situation C. That'd be another way to kind of think about it. All right. We know a displacement and the final velocity. If we knew acceleration, we could find the velocity at this point. So I know the final velocity here is 0. And if I know the displacement to go between here and there. So acceleration, let me tie it to a free body diagram with net force. This block of wood, well, technically it's the wood and the bullet together, right? Because they slide together on friction. There's a weight force acting on that system. There's no vertical shenanigans going on, so I know that normal force is equal and opposite in strength to gravitational force. As the block slides to the right, there's an opposing force. Friction has been identified. Must be the opposite direction. So net force is equal to mass of the system times acceleration of the system is also equal to the sum of all forces, and in that plane there's only one force. Mass system times acceleration system is equal to force of friction. What's force of friction? Mu times normal force. Well, in this situation, normal force is equal to gravitational force and magnitude. We've determined that through analysis. And Fg is equal to m times g, divide both sides by mass. And my acceleration will be my coefficient of friction times g. Coefficient is 0.25. G, 9.80 meters second squared. So acceleration of the system, 0.25 times 9.8 equals 2.45 meters per second squared. Okay. This is during the slide. This is during the slide. This is when friction is happening here. So, I know my final velocity, I know my D, I know my A. So I can take this now. Oh, I gotta go answer that phone. Give me a sec. Almost finished my solution. He may need help. Okay, thank you. Got my visitor coming in just a second, Mr. Britt. All right, we're almost finished this solution. Let's see. So VF squared is equal to V initial squared plus 2AD. I know this, and at the end of this, I come to 0. So this initial velocity here that I'm about to solve for is going to relate to the velocity right here after the collision before the work done by friction. So we're going to subtract over that 2AD, and we'll square root it. That'll give me initial velocity. 2. This is a one-dimensional problem. Your signs are real important here. My displacement is going to the right, but my acceleration is to the left, right? I start with strong positive to the right velocity, but it becomes less and less positive, less and less right, so it's becoming more left. So the sign for my acceleration here should be a negative 2.45 meters per second squared. Displacement is forward, positive value 9.5 meters, 9.5 meters. Square root the whole thing. That should be my initial velocity after collision. 2 times 2.45 times 9.5 equals square root it. I got initial velocity here of about 6.9296, we'll call that. All right, and that's the velocity of the wood with the bullet inside. No. Yeah, that's the wood and the bullet traveling together through this friction, right? All right, so that's their velocity together after collision. And we need to find the velocity of the bullet initially. So we're going to take this. And I'm going to say momentum is being conserved. So momentum of the system initial is equal to momentum of the system final. What actors do I have here? The wood and the bullet. Momentum of the bullet initial plus the momentum of the wood initial is equal to momentum of the bullet final plus momentum of the wood final. This is before and after collision, right? Before and after collision. Initially, the wood is not moving. So no momentum there. So mass of the bullet times its initial velocity before collision is equal to, well, this is just the total system momentum, right? Which is the mass of the system times that final velocity after collision. Looking for initial velocity of the bullet, so I'm going to divide both sides by mb. So mass of the system times velocity final after collision divided by mass of the bullet. All right, mass of the system. These two jokers together. 0.015 and 1.1. So 1.1 plus 0.015, 1.115. 3 1s and a 5. Velocity, there we go. The initial through the friction experience was the after of the collision experience, right? Same value, this up here. 6.9296 meters per second, all divided by mass of the bullet, which is 0.015 kilograms. Come on in, Wes. And grab a calculator and punch this up. 1.115 times 6.9296 divided by 0.015 equals. I get initial velocity of the bullet of about 515-ish meters per second. Pretty fast bullet. Pretty fast bullet. All right, well, there you go. We'll take it. And that's that.